becomes more. Before we begin, a few words that really matter, so stay with me for these. Everything you are about to see runs inside an isolated lab that we own and fully control. ATTACKRX is a character, no real company is targeted and no real system is ever touched. We reveal how the attack works for one reason and one reason only, so that defenders like you can learn to catch it. Never use anything you learn here against a system you do not own or that you don't have clear written permission to test. Unauthorized access is illegal, and what you choose to do with this knowledge is entirely your responsibility. So let's use it the right way, learn, secure, and defend. Now let's begin. 3:17 in the morning. Becomes more inside a quiet data center. A single Linux build server named Build01 is doing what it always does, compiling code for a game studio. Its dashboards are green, its alerts are silent, and on the security team's wall of monitors, nothing is wrong. But someone is already inside. Earlier that night, a developer's password was phished, and right now an operator we'll call ATTACKRX is sitting on Build01 logged in as that developer, not as an administrator, just a normal user. And that tonight is the whole problem to solve, because a normal user can't do much damage, but root, the all-powerful account on a Linux machine, root can do anything. So the question ATTACKRX is about to ask is deceptively simple. How do I get from developer to root? Welcome back to Cyber Talks. Becomes more. I am Gautam, and here we play both sides. Today we are breaking down one of the most common and most misunderstood Linux privilege escalation techniques in the real world, abusing sudo and something called sudo caching. In MITRE at 3, this is technique T1548.003. We'll watch ATTACKRX pull it off in a lab we fully control, and then we'll flip the glass and learn to catch it. So let's start with the tool itself, because understanding sudo is the whole game. Sudo stands for super user do. Think of it as a locked key cabinet on the wall. Instead of giving every employee the master key to the building, you give them one small labeled key for the single door they actually need. That's the intent controlled temporary power. Becomes more, and the list of who gets which key lives in a single file /etc/sudoers. But here's the catch, the one that makes tonight possible. Sudoers is only as safe as the person who wrote it, and administrators trying to be helpful constantly write rules that are far too generous. ATTACKRX doesn't attack the machine, not yet. The very first thing a good operator wants to know is simply, what am I actually allowed to do? So he asks Linux a question, and the question is sudo -l. This command prints every command this account is permitted to run with elevated privileges, and look at what comes back. One line, developer may run as root with no password required. The program /uss/bin/find. Becomes more. Let me translate that line field by field, because every word matters. As root means the command runs with full administrator power. No password, no passwd means Linux won't even ask for a password first, and the command it's allowed to run is find, a file search tool. It looks completely harmless. It is the entire breach. Here's why. Find has a feature called -exec. It can run another program for every file it finds. So ATTACKRX types sudo find a dot for the current directory -exec/bin/a shell and a semicolon. Now watch what happens. Because sudo launched find as root and find launches the shell, that shell inherits root's power. The prompt changes from a $sign to a hash. ATTACKRX runs homie and the machine answers root. Becomes more. One line, no exploit, no malware, no 0 day. Just one careless line in a config file, and a normal developer account now owns the entire server. Attackers even keep a public catalog of these tricks, trusted programs that can be turned into shells. It's called GTFO bins. Now there's a second door in this technique, a quieter one, and it's the part most people miss. It's the caching in sudo caching. When you run sudo and type your password, sudo doesn't ask again for the next 15 minutes. It writes a timestamp to get into /run/sudo, and for that window sudo just trusts you. It's a convenience, but imagine an administrator ran sudo just a minute ago and ATTACKRX is sharing that same session. The password is already cached. Becomes more. So attacks can run sudo and never be challenged at all. That's why on sensitive systems that little cache window is something defenders think very carefully about. So that's the offense. Now let's switch sides completely and sit down inside the SOC. And here is the uncomfortable truth. On the security wall, everything is still green. There is no suspicious network traffic because none of this touched the network. It all happened locally on Build01, and this is the single most important lesson in this episode. Privilege escalation is a host level event. If you are only watching the network, you are blind to it. To see this, you need host telemetry and specifically three sources. Audit the Linux audit daemon. Becomes more the authentication log auth.log under the auth pre facility, and ideally sysmon for Linux, giving you full process creation events. Without at least one of these forwarded to your CM, there are no logs, and with no logs there is no alert. So a strong defender does not sit and wait for an alarm. They hunt, and a hunt always starts with a hypothesis. Ours is precise. If someone abused sudo to escalate, then somewhere I should see the sudo process launching a shell. Because think about it, a normal admin uses sudo to restart a service or edit a file. A normal admin almost never uses sudo to spawn /bin/ directly. That pattern, sudo immediately becoming a shell, is rare, and it is loud if you're listening, and there it is. Becomes more in the audit log and execfee event. Parent process sudo child process /bin/ush running as uid0 root at 3:17 in the morning from a developer account that is not an administrator doing maintenance. That is an escalation. The quiet hunt just became a live incident. Now we turn that one finding into a detection that runs forever in Microsoft Sentinel using KQL. We read the syslog table, we keep only the events where the process is sudo and the message contains conrand equals, and then we filter for the telltale payload /bin/bash vim find out python. We are not matching a virus signature, we are matching a behavior, and that is what makes it durable. Becomes more the attacker can change their tool, but they cannot change the fact that sudo had to launch a shell. Here is the exact same logic in Splunk against the Linux secure source type. Same idea, sudo plus a command that opens a shell laid out as a table user host command time and outcome. Two different platforms, one behavior. Now one professional note, because this matters in the real world. This rule will occasionally fire on a legitimate engineer using sudo bash during maintenance. So you tune it, you explode your known break glass accounts, you correlate with your change calendar, and you raise the severity when it happens at 3 in the morning from a developer account instead of at 2 in the afternoon from a senior admin. Becomes more context, turns a noisy rule into a sharp one. Now we investigate, and investigation is always about the timeline. 9:14 an SSH login as developer, 9:16 the sudo bash l permission check, 9:17 the sudo find command, 1 second later a root shell, 9:19 our detection fires, 9:20 an incident is opened, but the analyst's job does not end at escalation happened. The real questions are, what did that root shell do next? Did it add a new user? Did it drop an SSH key into authorized skies? Did it write a cron job? For persistence, privilege escalation is almost never the goal, it's the doorway, and your job is to find out what walked through it. So how do we shut this down for good? Becomes more prevention. Here is configuration and then monitoring. First, the sudoers file. Least privilege always, no wildcards, and never grant sudo on shell capable binaries like find vim awk or less. Second, kill the easy password bypass. Avoid no pass WD on anything sensitive. Third, tighten the cache. You can set doubters timestamp towant to 0. So sudo asks for a password every single time, closing that caching door entirely. Fourth, turn on audit on every host. Add a rule to watch execute and forward those logs to your CM. And finally, review your sudoers file regularly, because the dangerous line is almost never added by an attacker. It's added by a well-meaning admin months before the breach. Let's lock this in interview style, because you will be asked this. Becomes more, what is sudo and what file controls it? What is GTFO bins? How exactly does sudo caching work, and why is it risky? And which log records sudo execution? What's the one behavior your detection should key on? Pause the video, answer each one out loud. If you can, you don't just know this technique, you own it. And with that, the thread is content. Build 01 is locked down, XC Cerberus is protected. Tonight you saw how a single generous line in a config file turns a normal user into root, how sudo caching quietly removes the last barrier, how we hunt for the one behavior that gives it away, and how to close every door behind it. Before you go, thank you truly. Becomes more. Every minute you spend here is a minute you become harder to breach, and that is the whole point of this channel. If this made even one attack easier for you to catch, then we did our job tonight. So do a few quick things for me. Subscribe and turn on notifications so the next breakdown reaches you the moment it drops. Leave a comment and tell me which technique you want to see next, and share this with someone in the cyber world who needs it, because the more defenders who can see this coming, the safer all of us are. Thank you again for spending this time here. You've been with Cyber Talks with Gautam. Attack, detect, investigate, defend. I'll see you in the next one.